Welcome back, everybody. This break was a bit shorter, so I hope you got a nice cold drink just in time. Today, the next session is by Gian and Paolo Santopaolo, who's going to talk about gRPC. And my co-host for this session will actually be the speaker from last session, or at least one of them, Jyoti Singh. So in a second, Gian and Paolo Santopaolo will take it off and tell everything you need to know about gRPC is the new WCF. Okay, that's a lot of letters, but there we go. Okay, Gian, please do your thing.
Hello, everyone. Last time I was at Future Tech, it was in person, so I was able to say hello, Amsterdam. Now, let me say hello, words. So, without further ado, let's talk about gRPC. What is it, gRPC? gRPC stands for Remote Procedure Call. The guys at Google, they don't say G stands for Google. By the way, this framework was developed starting 10 years ago by Google and then open sourced. It's a modern high-performance RPC framework. It's based on HTTP2, and this is very important. We will come back to the HTTP2 thing later in this course. It's based on protocol buffer and other modern standard-based technologies. So, first thing about gRPC to say is that it's payload agnostic. This means that by design, it works with protocol buffer, but other serialization types are also configurable. The architecture is extensible via filters, and via filters we can create custom authentication, tracing, load balancing, and whatever you can imagine you can plug in a communication framework. It works with many transport, but by default it uses HTTP2. And to be honest, even though if it's possible to change the serialization, the transport, for me, the real match and the real game changer is gRPC used with the HTTP2 transport and the protocol buffer serialization. We will talk about this in this speech. So, about the HTTP protocol, as you may know, this is something that it's a technology, it's a protocol that is we are using it since years, since ages. If we think at the phones that we use, the technology that we use, laptops, the technology lasts just a few years. The HTTP protocol is something that is here since a lot of time. And then in 2009, something important happened because Google started working to an extension of the protocol, codenamed Speedy, that then they changed it to HTTP2 in 2015. Why this is important? Because as we know, previously in HTTP1, we have limited parallelism. For every HTTP connection that we are gonna establish with the server, the HTTP connection is based on a one-to-one relation with the TCP connection. So the initialization of this connection is very expensive. And also the number of parallel HTTP requests that we can do, that a client can do, is equal to the number of allowed or possible TCP connection that the device is able to do. So in HTTP 1.0, without pipelining, we have one request. Then the client can make one request, then we have to wait for the reply for the server, whatever it takes, long or not. And then a new request, then the client can make a new request and wait for the new reply. This was causing, it's something that was blocking. It was really slowing down the process. even though this slowness comes to the clients, and the users was able to envision it when the internet speed connection was growing. When HTTP 1.1 comes out, there was the new concept of pipeline. So several requests can be made in a pipeline, but one request needs to still wait to the reply for the new request before making the new request. And the pipeline, yes, is there, but then as you see, there is the problem. The real problem was the head of line blocking. So we need the client need to wait for the server response before making the new call, even though multiple can be made in parallel. One more thing that is affecting the HTTP 1.x protocol is the overhead of the HTTP headers, that they are uncompressed in plain text. And on top of that, for each HTTP request, all the headers needs to be sent to the server. So this is something really overwhelming. And what Google was doing with the HTTP 2 protocol, it was to extend the HTTP 1 protocol to improve all the leakage, all the stuff that was causing bottlenecks in the version 1 of the protocol. So the head of line blocking problem was addressed, and it's not required anymore to have multiple TCP connection for having multiple HTTP connection. This is big, and it minimized the protocol overhead a lot. So how is made the HTTP 2 protocol? We have the stream, that is it's a bidirectional flow. So this is a new concept. This is bidirectional. With a connection, then the server and the client can talk in a bidirectional way. We have the message, and the message is composed of different frames. So that's how the HTTP binary framing is composed. Now let's see how the request response happens in the HTTP 2 compared with the HTTP 1. In HTTP 2, we have one connection, so we send the header one time, and then we can send back several streams of data by sending only one header one time. And the same connection remains open, and so that really the time for doing the same action, as you can see in this slide. Okay, apologize about that. The Shift F5 seems not working, so I need to do this. Okay, here we are. So these are the sequential read without pipelines in HTTP 1. The pipeline, the read with the pipelines in HTTP 1.1, and then the interleaved request. We will come back to this concept in a moment. In HTTP 2, you see that the time here is really reduced, and then we have the interleaved request with push, and this is another way of doing HTTP 2 where the time is really reduced. So that's why basically the request response in HTTP 2 is way faster than in HTTP 1. If we want to test it real quick, hoping that then the combination for starting at the same slide, it will work. It's the HTTP demo IO. So if we go over there, so what we have over there, we have this image is composed by 200 small images, and this is how it's loaded in with HTTP 1.1. If we run the same on HTTP 2, you see that the speed on how the image compares is like it's visually. You can visual it one more time, and then if we open the okay, here we are. So let's see what's going on over there. Okay, let's do it again with the developer tools open. Okay, here you see, first of all, we have the protocol and then the connection ID that is different for every little pieces. And this is the waterfall, the sequence, how the image are downloaded. Now, if to this we had the version 2, the HTTP version 2, first of all, we see that the protocol is version 2. One very important thing, connection ID is always the same. You see, and the waterfall here is like they all started together, right? So this is really why the HTTP protocol 2 is very, very important. So let's see if now, okay. I am able to start the slide from the position, okay? Okay, so in terms of difference between protocol buffers, so the serialization. So something is the transport, then in the transport we have the serialization that gRPC is using. In this case, protocol buffer, that is a binary serialization. If we compare it with the HTTP 1.1 JSON serialization, so a text serialization, and these are data from official data from Google, we see a 3 times increase in throughput in a virtual machine on the Google cloud, and a 11 time difference in CPU utilization. Now, what does it mean? With all the mobile device that we have nowadays, this translates also in less CPU usage from the device, that you can easily translate in a less battery usage for these devices. Not talking about the speed and the responsiveness that you have in the case of such kind of serialization, right? So what we are talking about? We are talking about something that is really performant. And usually when I develop software, what I tend to do, especially on the server side, is to develop software that it performs at the best. When we talk about scaling, for me, scaling, it means, first of all, scaling at the software level. And then when it's not possible to scale anymore at the software level, then, okay, let's scale by increasing some more hardware. So it's really a state of mind. If you think that way, there is no way that you cannot think about using gRPC in your application, right? So another very important aspect of gRPC is that it's natively implemented in lots of language. We have main implementation in C, C++, Java, and Go. And then from the C, C++ implementation, we have C#, Ruby, Node, Python, PHP, Draft, Swift, lots of implementation. So this really means that we can create an application that is interoperable and it can communicate each other. Different operating systems can interoperate, can communicate each other. When I see a slide something like this, where I have on one side C++ and Java, I cannot think about this animated GIF where we always know that what's the fastest, Java or C++, right? Well, Standing at the words of J. Newton King, the father of JSON.NET, the serialization that always, the package that you shall know, he is now a Microsoft employee working, he's working kind of hard, he's pushing hard on gRPC, and this is a tweet he published some days ago. It's from August 4, where these are the results in terms of performance of gRPC on .NET 5. So if I look at this performance test, and if I think to all the mindset of the performance, well, maybe this time it will be .NET the fastest. Let's see. So now let's talk a bit about protocol buffer, because this is where we are going out of our .NET developer, C# developer. We are going a bit out of our comfort zone, because this is something developed by Microsoft. I have a problem with my camera. Let's see if I can fix fast. Okay, we shall have it back. Sorry for that. That's the inconvenience of the online conferences. By the way, let's go back to the protocol buffer. Protocol buffer is a standard written by Google for serialization of data and storage. It represents the data in a binary format, and the structure can be maintained for backward compatibility. It allows code generation in many languages, including .NET, .NET Core, and this is very good for us. And we will see when we will put the hand on the code. It's strongly typed, and it's not required by gRPC, but as I already said, to me, they make the perfect match. So about protocol buffer, this is needed if we really want to push gRPC to the max. Understanding the language is just a single page on this Google document. It took to me half an hour to understand how I can represent my entities with protocol buffer. So if you are really going to use gRPC, then you shall go here and have a look, and promise you in 10 minutes you will be able to understand how to create how to define a type in protocol buffer, and we will see, by the way. Okay, how we can use gRPC? We can use gRPC with the unary type. So when the clients send a single request to the server, and it gets a single response back, just like a normal request, right? This is the protobuf file that we need to define. And there is an important thing to say about the protocol buffer definition. We define the same file on both the client and the server. You remember that we have a native implementation for gRPC and protocol buffer for different languages. So I can share it with iOS developer. I can share it with PHP or even with the web, but with some little difference. So we have one definition, and this is the representation of our service and the type, because it's strongly typed. It is used. And so you see here, we have the request message, and it's strongly typed. It's also, it's very similar to .NET type. And this is the way to use it. Here we are defining a service. In this case, a sensor service. The use case I'm going to use in the sample in this course is like thinking about having several IoT devices around the network, connected somehow to the network, and they need to talk with the central server. Right? So here a single device wants to know wants the list of all the available devices, right? So as request, he sends the username and the message, and it gets a response with the devices, basically. This is the code that we are gonna run on the client. We are creating a gRPC channel. We are creating a client, and then this is the server call, get available sensor async. That is this get available sensor. We are passing the object, in this case, a available sensor request. And we are getting back the response in the form of a reply. We will see. We have all the source code. I'm going to share with you all the source code for this sample, and we are also going to discuss it together. The second type is the server streaming. So the server streaming, this is happening when the client sends a request to the server and get a streams to read back. So. So what's happening is that you can, when we define a server streaming, you can see that is a streaming because there is this keyword in the message signature. So we have here the server streaming that is receive temperature updates. So the single client wants the updates about the temperature, and then once it sends this request to the server starts not sending one message, but starts streaming it until the client sends signal to the server. I don't want anymore receive this stream. We have also the other way around. So the client streaming type. The client streaming type, you see here is defined, here is the signature. So we have stream sensor data. So here the client, the device is streaming to the server its own data. And the server only responds once at the end of the stream that its response. Okay, here I was trying to make the same signature, but let's say with a void type. So we will look at this sample also when we are going to look at the source code of this stuff. This is the client representation. And then the last but not least one is a bidirectional streaming. What we can do over there, again, the word stream, it makes you understand that is what's going to happen. Here you see in the return types we have stream, so it means that the server is streaming something. Here we have the stream in the argument, so is the client passing something to the server. This means that the client is streaming something. Here we have, you match this together and we have a bidirectional streaming where you send something, the client is sending something to the server and the server is making another stream. These are two different streams, by the way. They are not connected. Okay, now let's go do some code. Okay, so by the way, the code is over there. At the end, I have all the links for you. This is my GitHub repository, and here there is all the code that we are going to see today. This is not the first one, so let's close it and let's open the first one that I want to show you. It's the unary type. Okay. So first thing first, let's move this. Okay, the proto definition. This is the proto definition, and as we said before, at runtime, the Visual Studio is able to create several classes out of the proto definition. Okay, now. We also said that the proto file is shared between the client and the server, right? So I don't want to create this file twice and share it, or creating a version on the client and a version on the server. I want only one version. So what I came up with is something like this. This is the unary where I have, this is the server, and here we have this code. Here in the folders, we have the client, you see, and this is the client. And then I have only one Protos directory at the same level of the bot where my file is defined. If we go and see what we have here, okay. Okay, it's here. You see, with this directive, we are saying to the project that this is a linked file, and where is it on the file system? This is good for a sample, for making some sample approach. In a real world, in a production environment, I have to tell you that there are other ways to make such kind of thing. Imagine if we can create, for example, a NuGet package and distribute it all over the different client that they are, different teams that they are working to the same project, right? So at IBV, the company where I'm working for, we are looking forward in switching to the gRPC, and we are also talking about some DevOps approach to maintain such kind of file. Imagine that way the productivity will raise a lot, because usually what we are doing at the moment is that we define the types that we are going to share through our APIs. And then the web developers, there are someone who is caring about creating out of our C# types the corresponding JSON types. So this is double of the work. With this approach, with the Protos approach, you don't have to do it anymore. So this is really important. Okay, so let's go back to the Protos file. So this is the first thing we need to define. So let's say the scenario is I want all the available sensors, right? So I need an object for the client to pass as an argument with the username. This is a sample, of course. And it will get back an object, okay? And with the list of devices, okay? This is very, very simple. Once we are done this, what we can do is we create a class that is inheriting from the auto-generated code. If we go there, this is code, you see. This is in obj, in the obj folder, because this is auto-generated by the protobuf framework, and it changes when you save this file. When this file is saved, I can show to you. Let's see if I can show you. So this is the service proto. We have the sensor av, available response. Go to definition, available response. Okay, this is getting. By the way, this is the file that gets saved as soon as we save the proto file. Okay, so we are extending the service, the sensor service base. In this case, we are creating, we are having the constructor with the logger that is injected by the ASP.NET ecosystem. And then we are going to override the service definition of the method. And this is, so here we are logging some information, and here we are sending back the information to the client. For the application to start up the service, the only thing that we have to do is to add the endpoints. So yes. Here it is. Here we are mapping the service, and here we are getting the endpoint, right? And this is the server. Now let's have a look at the client. At the client, one other important thing to say about the protofile is that you see in the properties here we have this field, this property that say gRPC stub classes server only. So here we are saying generate the code that I need for using it in the server. And here we are saying generate the code that we need for using on the client, right? Okay. Once we have this on the client, this is just a console application. And by the way, now with projects that they are not console application, for example, with WPF application, you can add a connected service, but not on the console application. So here again, I did the little trick of editing the project file, and here this is the statement. I'm saying to link the same file, the same proto file. Once this is done, automatically the code is generated under the hood. We can go and check it out. You see, this is client obj, and this is the client. The client that we need. So what we need to do is to create the channel, the client, and then invoke the service with our arguments. In this case, I'm passing username and message, and then we're gonna see the response. Let's see this in action. Okay, this is my server. This is my client, and as you see, this is something that it requested something and it retrieved it. So this is the client, right? Now let's see it again. Where is my client? Here it is. So let's close this and now debug. Start a new instance. Okay. Is opening the channel, is opening the client, is creating the request. The request went to the server, and then we have the response with the message from the server. Okay, let's close everything over there. Okay, and now let's do it again. This is the server, by the way. Okay, and so here it is. It's a bit bigger, but I hope it's okay for you. Okay, so if we do it again, tack, and here we are. This is important because now you're seeing in the same, sorry, in the same Visual Studio, in the same in Windows in parallel. But here we went from one side of the world to the other side of the world, from the client to the server, and the server now is doing his stuff, is creating the response, and it's sending back to the server. Of course, now I broke it because of some too much time I took in the breakpoint. Okay, so this is the first sample. It's nothing that you, let's say, from a logical point of view, you don't know, because this is like a web request response works, right? Okay, now let's do something else. Now let's do the client streaming. So the client streaming, of course, is the same story with the trick for the linked file that we have over there, server streaming with the protos, client and server. We define the proto file that actually is the same. I'm just adding something else, you know. So this is an incremental sample that I'm showing to you. So this is the client is sending a request, and then the return is a no, sorry, the client is sending a stream. So it's sending a stream of data. When it's done, then the server returns returns the one single response. Okay. So here we have on the sensor hub, again, this is the unary stuff, and this is the client streaming. So here it is. Here it is what we have. There is a for each until the stream is open. Okay, and so we are doing some action. This is a sample. We are in a real world example, in a real world scenario, we are going to make some business actions, save something, persist something somewhere. And let's see the client part. So the client part is the send streaming data async. Here in this case, what I am doing is here it is. You see, here I am sending 100 requests. I'm streaming 100 times, 100 message to the server, and then I am completing the stream. This is the case where usually a sensor say, hey, I have something to send you, to tell you some information, some parameter I collected, and now I am going to stream them to you. Let's see this in action. So we have the server is receiving the data, as you can see. Now we are going to add some debug information as well. Okay, so we can better understand what's going on. Okay, so this is the client. Let's add a breakpoint over there. And let's not add the breakpoint to the server in this moment, because otherwise we are going to get some timeout exceptions. So let's put this in parallel, by the way, side by side. So then this is going to get over there. Okay. Send sensor data, send sensor data. Yes, here it is. And this is the last response. Okay, after the 100 call. Let's say, let's make it short. Let's make it 20. Okay, so let's start. I say no breakpoint on the server. Okay, so here we are sending something. Okay. Here is something is going to crash. Okay, to prevent and self-report. Okay, this is a bit too big. Let's see if we do like this. Okay. Okay, you want to send. Okay, let's try this again. Okay, now it's good. And here it is. This is the information that we are getting from the client to the server. 1, 2, 3, 15, 18, 20. Okay, and then we shall have message streamed received correctly, right? This is the client streaming. And I find it, if I think to it, I can find lots of usages for it in the development I'm doing day by day. This is we saw the client streaming. Let's now see the server streaming. So the server streaming, it's again the same proto buffer, and here we have In this case, the stream is the temperature data. So the client is sending a request, hey, can you stream for me some data back? And the server will start streaming it. Let's see the implementation. So these are for the client streaming. We don't need anymore. And this is for the receive temperature updates, right? So receive temperature updates, it writes to the stream async something, device location, it's null. We can do something like location here, location, say with okay. And yeah, and we have the client. This is the client streaming. We don't need it anymore. This is the unary. We don't need it anymore. And this is the server streaming. Okay, so the server streaming, you see, so cancellation token so that I can decide when I don't want it anymore. In this case, in 5 seconds. And then it's sending a normal request and say, hey, send me the temperatures, and I am also sending ahead the cancellation, the cancellation token. Is receiving the data, and then at some points it will end up. So let's see how it works. This. Okay, the server is sending something and the client is receiving. 5 seconds are passed and we got the server that it closes, right? This is nice, and this is the nice part on the client where is receiving, is reading the stream, so it's receiving what the server is doing. Okay, and this is the server streaming. Again, it's nice, but now let's go ahead and find out something a bit more interesting, let's say. So here we have the bidirectional streaming, okay? What do we have right now? We have the server, one server, and here the premise for this sample is to have multiple clients, because the purpose of this sample is really to show you you can go and see the Microsoft sample. They are all the same, all basic stuff. This is something that you can really use and extend in real life. Why? Because this is something like I have one server, several clients. One client is streaming his own data to the server, and then though his own data are broadcasted to anyone connected. Connected where? To a chat room, to a server room, to a game room, whatever. So these are the mindset which I did this server, this sample. This is the starting point where you can easily create a game server, right? So again, one client, a different client sending data, and the server is broadcasting to everyone but the sender the data collected. Okay, so this is a bit more complicated. So this is the unary, this is the client, this is the server, this is again something that we don't need. Here it is. So for doing that, what do we need? First of all, I need some queue where to store this data. Okay, so I defined here something that is static, because keep in mind that every connection will create an instance server side of the sensor app CS, right? But the queue is where I want to put all the data, because then it needs to be broadcasted. So that's why it's static. So it's one object for all the application life cycle. And here what I'm doing is I am adding to this queue the sensor ID. That's how I identify who is the sender, and the stream that he is sending. And then I am broadcasting the message to everyone in the queue but the sender, right? So, and if something happens, it mostly means that in this case, let's say the exception means the client is not reachable anymore, so we are removing it from the queue, okay? But keep in mind, this is just an example, okay? In real life, I would have done these things in a different way, in a more complete way, but this is not the scope of this sample, by the way. On the client, what do we have? We have something that is a bit more complicated, but nothing that exceptional. So first of all, we need the unique ID for the sensor. Remember that we need to run now multiple instances of this client. And then what we are going to do is we are going to run in a separate task the return stream, the stream from the server. And instead, this is the stream that the client is sending. In this case, the client is waiting for a letter, for a digit on the keyboard. If it's Q, then it breaks down, okay? Otherwise, it will send some random data. And this random data then are going to be broadcasted. So let's start this, but we need multiple instances of the... We need multiple instances, I said. So, okay. Debug, start a new instance, and this is device ID1. Debug, start a new, oops, sorry. Okay, device ID2, and then debug, start a new instance, and this is device ID3. So now we are ending up with 3 clients, right? And 1 server. Okay, so first client, send 1 message, sending data, and these are supposed to receive it. Okay, 1 second, because then this is a sample, of course. They need to register before receiving anything. So, okay, now they are registered, and now what we see is that if we send some data over there, the data is arriving to the server, and the same data, sensor 1 sent data, sending data 91, data 2, 15, 99, 91, 15, 91, 15. Here I go sending data 18.8, 18.8 from sensor 3. This is sensor ID 3, sensor 18.3. And again, this sensor data 14.10, 14.10 from sensor 2, 14.10 from sensor 2. Right? So I hope you enjoyed this sample. I have something else a bit more powerful to show you the power of this new communication framework. There is a message in the chat. Yes, I can. Let's say this is what's, let's see, the latest sample that I have. The latest sample that I have, it's something that, to really show you, it's like to understand how powerful is gRPC. So I'm going to create a couple of lots of threads. Each thread is creating a bidirectional streaming with the client, and then we are sending an enormous amount of data, right? And this is the code. It's a bit complex, but just a bit. Let's go and see. Let's go and see it. At the end, I will give you all the links. These are where you can find all the code. And this is running on 2 virtual machine on Azure with the augmented network, right? So let's say this is running the server, this is running the client. Here I have, let's define something like 500 threads, and I want my message to be 65K. These are bytes, so like this, right? The server is receiving. The server is receiving, and we are using 1.5 gigabit and sending and receive. And here is almost the same. The client is using 65% of the CPU, but we are sending and receiving 1 gigabit of data. Same here. This is a bit on steroid, this machine. So it's receiving the same amount of data, and these are the CPU usages that we have. So now, Steve, I don't know if I am out of time or not. Can you tell me? Can you give me a sign? Because I have a couple of slides more to give out, because we started a bit late, so I don't really know the timings.
Well, you are almost out of time.
Okay.
But if it's only 2 more slides, you could finish it up, of course.
Yes, because those are important. Let me close this machine, because they are pushing a lot, at least the client over there. So Shift F5, okay. Now, something very important for you to know. And again, at the end, you will have all the links. gRPC is not supported on IIS and App Service. They are working on it. There are 2 different problems on it, and this requires an operating system update. So it's really deep down the chain. You need to know this. This is a very promising technology. This is very powerful, but if you are using App Service or IIS at the moment, it's not working. How you can use it? Well, ASP.NET Core containers, right? Okay, so this is one of the bad news. Another thing is that at the beginning, gRPC was initially developed like a protocol to have a server-to-server communication. So there was no web support. Now we have, now the gRPC core, they are making support via Envoy proxy. On ASP.NET, we also have gRPC for web. This is the link to the article of, again, the guy from the JSON serialization stuff. And go ahead and read it, because it's very nice. You don't need to use an Envoy proxy anymore. There is one more thing there is one more sample left to do that I didn't have time to do, and I left you as homework. Now, there is this beautiful tutorial about generate and consume a synchronous stream using C#8. What do you think about having, for example, a server streaming? So the client is initializing the request, and then something like get all my users, right? And you go to the database, you read, in case of a SQL server with a SQL data reader, and you can return your items. As soon as you get from the database, you don't have to wait to complete all the reader to be done, but you can yield it. As soon as you get one, you can create an instance of an object back. This is for you. If you want to contribute to the repository, you can make a pull request if you want with this sample. So if you have some questions, I don't know, Steve, if we are out of time, I will be always on Twitter to respond, happy to answer. If we have any question now, I can try to answer. Sorry.
Hi, Gianpaolo.
Yeah, there she goes.
Go ahead, first time. Yeah.
Sorry, Joy.
Take the floor, Jyoti.
Yeah. Hi, Gianpaolo. Thanks for the amazing talk. There are some questions inside the chat box from Vincent. There is already a progress using gRPC on the web, not just for communicating between services. Do you believe this will one day also replace HTTP REST APIs for the web?
Well, to me, we are running a company where we are doing some integration works, but we have also our own products. One of the products is a real-time whiteboard. If you go and look online, Scalable is one of the biggest one. We got several prizes. We are running at the moment the communication is an hybrid communication between Web API and SignalR. I am pushing the board to get the budget to switch to gRPC all the way to the client. Yes, it's possible. It's not possible the bidirectional streaming, but all the rest you can. And there is the hard way with the Envoy proxy, and if you have a team of DevOps, that's not a problem. Otherwise, let's go and have a look at the article I introduced, the gRPC web for .NET now available. That could be also a solution. So definitely, yes, at least it's where I am pushing my company to go.
Thanks. Another question which we have from Luke is, would you still consider using HTTP REST APIs over gRPC?
Would you consider to use? Sorry.
HTTP REST API over gRPC?
I'm going all the way to, I am an old fan of the communication layer. I always been struggling with WCF and then with the rest. And yes, to me, gRPC, at least I am no one to tell, and it's just based on my experience. I'm going to move all the way to gRPC. If you have any question you can argue, like for example, yes, but then with JSON we are losing the fact that we cannot inspect the elements, the byte anymore, the data that they are transmitting. Let's talk about it, because there are tools that you can do. It's a powerful tool. To me, it's something like the biggest announcement in these 10 years that I see, that I experienced.
Perfect. Do we have time for more questions? Because there are other 2 to 3 questions available inside the chat.
Well, we're quite a bit over our time limits, to be honest. So I hope Gianpaolo can stay a bit in the Discord chat to answer some of the questions.
Sure.
Perfect.
Sure.
Well, first of all, I want to thank you for speaking for us.
It was a very entertaining and interesting session. And also, Jyoti, thank you for doing the moderating and acting as a host, of course.
Apologize for the little inconvenience I got during the presentation, but these are the things that happens during a pandemic.
Yeah, no problem. We're just happy to have you, just like last year, and hopefully for next year as well.
Sure. Maybe in person.
Yes, we all hope so, I think. Also the attendees, I guess.
Sure.
Well, then the only thing that rests me to say is thank you very much for watching.